make sure, if you don't already have that a blank sheet of paper, go ahead and take them out. This is going to be, you work on a timer, AK, on a timer, and then I work, okay? So I got a battery, let's make it 12 volts, and let's only give ourselves 3 resistors, just to make sure that we get warmed up here. Let's make this 2.0 ohms, 5.0 ohms, 3.0 ohms. I want to know what the equivalent resistance is, and then I want to know the current and the voltage for all the resistors, which there's only 3, so this doesn't take you very long. Equivalent resistance of the entire circuit, current, and voltage for all 3 resistors. Go. Okay, now, first thing that I want to do, I want to add these guys down, right? I want to add this down. What are the first 2 resistors? The most obvious ones here. 3 and the 5 in what? Parallel. Okay, the 3 and the 5 in parallel. So, working down, 2.0 ohms. How do I add resistors in parallel? The inverse equation, right? 1 over RT is 1 over 5 plus 1 over 3. Whenever you're doing this, please do not forget to take the inverse after you've done that. Thankfully, in the quiz, I don't think we have any problems with that. I think everyone will remember to take the inverse at the end. So what do you come out with for this resistor down here? 1.875?
Yeah.
Sure. We'll keep all significant figures to the very end, so that's just fine right there. Next, and this is really the last step before I get to the equivalent circuit. I've got only 2 resistors. How do I need to add them? Yeah, they're series. You just add them. So this comes out to be 3.875 ohms, right? That's it. So if I need to put the answer for total resistance, I'm going to come back up here, right? Total resistance looks like I got 2 sig figs, so that's 3.9 ohms, right? For that answer. Now I need current and voltage for each one. So let me go ahead and prepare here. Let's make a little table. 3.0, 5.0, 2.0. Let's do current, voltage. What's the unit for current, guys? Amps. Amps. 40.
But do we have to do stick figs on this one since you said necessarily it's not needed yet? Are you going to count off points?
I'm going to be better with sig figs. Round your answers to sig figs on the end, at the end on the test. So yes, like here, 2 sig figs and all the beginning numbers. And it's just as simple as, look at how many sig figs you have in your beginning numbers, and whenever you are going to report an answer, round off to the correct number of sig figs. Okay. Don't throw away decimals in the meantime, or in between steps. Keep those. All right. What's the only thing that I don't know here? The bottom. Current. So what do I need to do? Ohm's law, right? So this is V equals IR. 12 equals I times 3.875. What does I come out to be?
3.09.
3.09?
Yeah.
3.09 amps, approximately, somewhere in there. Okay? Keep all decimals right now, because you have a calculator. You can use the second answer function or the store function. Okay, the calculator, so you don't have to throw things away. Next, I work back up a step. I take that 3.875 and I'm working back up a step, meaning I expand them into what 2 resistors, series or parallel? I expanded them into series. What stays the same in series? Current. So I am able to carry over the current. I equals 3.09 equals 3.09. The only thing missing for those two, voltage. Use Ohm's law again, right? And this V is going to be 3.09 times my 1.875. Over here, this V is going to be my 3.09 times my 2.0. Okay, so give me those voltages, please, if you will. Voltage for the two?
6.19.
6.2.
Sure, we'll go ahead because we got to round that off. That is one of the final ones, right? So we'll go ahead and round that 6.2. Sure. This one over here,
5.805.
5.805.
Yeah. 5.8.
Here, this isn't a final answer yet, so I'm not wanting to round it just yet. You still want to use the store function, right, for calculator. So you're not throwing away decimals between steps. You only want to round once at the end of sig figs. Got one last step to do, right? I already know everything about the 2 up here, right? The 2 is the same as the 2 down here, correct? 2 in the final circuit up here is the same as the 2 in this circuit down here. So I can just carry all those numbers over. No, I mean, that's not a big deal. This has a voltage of 6.2 and a current of about 3.1 amps, right? The only thing that I don't know is the 5 and the 3. The 5 and the 3 came from the expansion of this 1.875 ohms, right, into what? Okay.
Bill, from the series to the parallel, you don't have to worry about the binding and worry about the two and the
The only thing you have to worry about is what changed. What changed? Since the presented this is what you're talking about. Clarify after I explain it. Now, since the 2 is the same, right? I didn't do anything to that 2 ohm resistor. It's the same there. All of the current and the voltage, the numbers that are associated with it, they're the same too. You don't have to touch them. They're done, right? The only thing you got to worry about is the changing. It's this 1.875 changed into the 5 and 3, right? It got split up into the 5 and 3, parallel or series. Parallel, what stays the same? Voltage. So I take the voltage from the 1.875 and I carry it over to those two guys because voltage stays the same in parallel. His voltage is going to be 5.805. His voltage, 5.805. The two voltages. Now the currents are going to be different, right? Currents are going to be different because of the different resistors. Okay, because of the different resistors there. How do I get current? Ohm's law, V equals IR. So let's just go ahead and report our actual answers. The 3 ohm guy has a current of what? Give me with 2 sig figs.
1.9.
1.9. Please do not forget units, amps. 0.9 amps. It has a voltage. Start with a little off here. 5.8 volts. The 5 guy. Current is what? 1.2? 1.2 amps, and the volts, once again, 5.8. 1.6. Which is it? 1.2 amps. Volts. 5.8 again. The 2. We already know everything about them. 3.1 amps and 6.2 volts. That's what you do according to me on the test, just like that. Okay, I'll have the blanks and everything already filled in. Yes and yes. Yeah. Good question. All right, so here with the 5, right here, forget it, right? I've got a V and I've got a R. What am I missing? I, right? I equals question mark. How do I find it? Well, I do Ohm's law. 5.805 equals I times 5.0. Right? Divide both sides by 5.0. I get that 5 equals what? Double check yourself at the end of these. Double check yourself at the end of these. V equals IR for each resistor, right? For each resistor. So 3 times 1.9 should give me, now granted we've been rounding, should give me about 5.8. If it gives me 5.7 or 5.9, I'm not counting. Okay? 5 times 1.2 should give me about 5.8. It's V equals IR, right? I'm taking the R times the I should get the V. 2 times 3.1 equals 6.2. If these numbers in the rows don't match up, right? If you cannot do V equals IR on each of those answers, then you did something wrong in there. You did something wrong. Okay, whenever I was grading the quizzes, that was one way that I could quickly double check. I would find that lots of you would have the right voltage, but the wrong current. And it didn't make any logical sense, because you'd say that this 5 ohm resistor that has a voltage of, I don't know, say 10 volts dropping across it, has a current of 25 amps going through it. That makes no sense, right? That doesn't follow the style, right? So you can go back and check your answers. Questions about this? Do we feel pretty good? Yes. All right, next. Let's expand it out a little bit. Yeah. Let's make this a 24-volt battery, 3.0, 2.0, 4.0, 2.5, 5.0, 1.5, all in regular ohms. Once again, I want you to find the total resistance and the current voltage that flows through each of those resistors. Remember, start from the most obvious. Most of the time it's on the outside. That doesn't necessarily mean in a linear fashion away from the battery, right? That doesn't necessarily mean that you want to go as far away from the battery and start there and gradually work in. It means you want to go as far to the outside of the circuit, if you will. The circuits are built outwards in somewhat of a spherical or circular manner, right? And then you want to go to the outside here, right? So what is the, and there's actually a lot of obvious ones to start with, so, and that's okay. What is the most obvious one to start with? Sure, 1.5 and 5.0 in series, that would be fine to start with. Other things that would be fine to start with. The 2 and the 4 in parallel, right? Sure.
Yeah, that's all I think.
I'm going to do them in separate steps, but you can do them all in one step. Things that are not fine to start with, right? Things that are wrong. The 1.5 and the 2.5 in parallel. Try again. You completely skipped over the 5.0. You just magically made it disappear, magically smushed things together. You broke rules. The 3 and the 4 in series. Nope, not happening. The 2.5 and the 4 in series. Nope, not happening. Okay? The 5 and the 2.5 in series, or the 5 and the 4 in series. Nope, not happening. You are crossing over wires then, right? You're crossing over wires, over intersections, if you will, when you're not allowed to. Start from the most obvious on the outside, work in. So, let's start from, just like you said. In fact, for the sake of time, I'm going to combine these two, right? And these two all in one step. Okay? So that's going to put me down to a circuit that looks something like this. Here's the 3. Here's the 2.5. 1.5 plus 5.0 is 6.5. And that bottom one in parallel, 1 over 4 plus 1 over 2, take the inverse, what do you get? 1.3333. All right. Next, most obvious. Which ones? 2.5, 6.5. Good. So this is still my 1.33, right? This is still a 3.0. And whatever you combine, the 6.5 and the 2.5 in parallel, what do you get? 1.805. All right, last step, equivalent circuit. All those are in series. So it comes out to be what? Approximately 6.138 ohms. And this is a 24-volt battery. One thing that I'm missing here is current. So I'm going to get the current using V equals IR. I equals 3.99.
No,
3.909 amps. Next. Okay, and that's just V equals IR. Now I'm going to work backwards. Okay, I'm not going to show all my work right here just for the sake of time, but I will point out this is all using Ohm's law. The trick is to remember what to carry over.
You write like a, I was kind of wondering, like a equation form? Like what,
No, there is no equation form for that. You cannot have what stays the same and what divides on your equation sheet.
but it won't look like that.
It's next.
It's like an equation, you won't know.
No step.
No,
Now, what happened next? I went from the 1.38 to what? Series or parallel? Series. What stays the same? Current. So every last one of these guys gets a I equals 3.909. One thing missing is what? Voltage. Use V equals IR. We won't go through all the calculations of it, right? Voltage for the 3.0 equals what?
12.
12. About 12 volts.
Yeah,
Voltage for the 1.33?
Not going too much.
Voltage for the 1.805?
7.05.
7 point what?
05.
7.058. Sure. We good so far? Yes. We work up another step. Now, the 3 stayed the exact same, so I can just copy down everything that was there. And 3.909 amps. I don't have to deal with anything on the 3. Who cares, right? It's the same thing. Things that did change, though, and the 1.33 is the same too, right? So 3.909 amps and 5.21 volts. The only thing that changed was that parallel. I took the 1.805 and busted them up in parallel. What stays the same in parallel? Voltage. So that means I can apply the 7.058 volts to each of them. Right? Now I have voltage. That's all remembering what stays the same. I get to solve the current. Current for the 2.5. What is it? 2.8. Current for the 6.5. Just using Ohm's law.
1.08.
Wait.
1.08.
1 point of it. Then you take that back up to your final one. You find everything. Pause. Your test is tomorrow. It will not have power on it. I am not concerned with that. I am concerned right now with the circuits. Study hard.